Okay, this is problem 14 then, evaluate these expressions. What we're going to find, and I'm going to do this for the rest of the problems to kind of speed this up, but what you're going to find is that when you have a base 2, and then you have raised to an exponent log base 2, or even if you have it the other way around, you're going to find it always cancels the 1 and this thing comes down. And I'll show you why. The reason why is because if you change this into log form, it'd be log base 2, right, of x equals log base 2 of 3. So this is exponential form right here, and this is log form. And so you have, imagine that this is a number, because that's all it is. Imagine it's like 1. Well, you change it to log form, you do log base 2 of this equals the exponent 1, which this is now 1. So to change from exponential form into log form, it's, you just do log base goes here, and then the exponent always goes here because a log is an exponent. So what that means then is that you can compare this to this and see that this really equals 3 because x is 3. X is 3. So basically every time, to make it simple, we can just cancel these. This is 3. This is log base 10, so these cancel and you get 4. And this is log base e, so these cancel and you get 2. The same thing happens, I can show you that again with natural log. If you have e to the natural log of 2 equals something, let's call it equal to x, you can make that natural log base e, which you don't have to write, of x equals natural log of 2. Well, you can compare. See x equals 2. So that's how you get that. Next problem, we're going to change in the exponential form, so it's base to the exponent equals the argument. And we're going to simplify this to 3 to the x equals 1 over 3 squared. And we're going to simplify it to 3 to the x equals 3 to the negative 2. Now we can see x equals negative 2. Okay, if we do the same thing for the next one, it's 10 to the x equals, and I'll write 6 squared to 10, and then I'll simplify to make this 10 to the 1/6, and now you can see that x has to be 1/6. Same thing for the next one. When you have base to the exponent equals the argument, you want to simplify, so you have 10 to the x equals 1/10. I'll make that 10 to the x equals 10 to the negative 1, so x equals negative 1. Next problem then, same thing, I'm going to do base, which is e, to the exponent, which is x, equals the argument, which is e to the negative 7. You do that, this is negative 7. Same thing for the next one. Base to the exponent equals the argument, x has to be 9. And last one, base to the exponent equals the argument. Now I'm going to rewrite that as e to the negative 1, and so x equals negative 1 there. All right, next problem. Once again, if we have log base 11 of 11, that always cancels. And you always get what's there. So the answer is negative 9x plus 8. And if you want another way to look at that, you can rewrite this. You can say that this thing equals something like x, or not x because they're already using that variable. Like, let's say z. You could then do base to the exponent equals the argument. And then you can compare and say that, well, z is what we're looking for, has to be not negative 9x plus 8. So you could rewrite this in exponential form and compare, but basically every time that you have, base something of that something, that always cancels, and you get negative 9x plus 8. Same thing here. If you have other way around, if you have a number raised to the log, that cancels as well. And if you're not sure why, I can show you why. If I have 12 log base 12 of, let's say, x, and I want to know what that equals, well, I can do, it's in exponential form, so I can do log form, log base 12 of y equals the exponent, which is log base 12 of x. So you can see that that this whole thing just equals x, right? Y equals x, so this whole thing has to just be equal to x. Same thing here then, these cancel. So basically you just end up with negative 6 minus 10 cubed. And then the next one looks a little more difficult. I have 25, I call this equal to something like x. I have 25 to the x equals 0.04k, because that's changing it into exponential form. Now let me rewrite this. This turns into 4 over 100 raised to the k. And I can simplify this some more. This turns into 25 to the x equals 1 over 25 to the k. And I'll make it 25 to the x equals 25 to the negative 1 to the k. And it's not hard to see then, if I rewrite it one more time, by multiplying the negative 1 times the k, that x has to be negative k. So what I called x at the beginning is really just negative k. That's what I want. And then the last one, once again, I can rewrite this in log form. It would be log base 10 of something, whatever this thing equals. I'll call it z this time. Log base 10 of z has to equal the exponent, 9 log base 10 of 6 minus 6 log base 10 of 9. So I've written it in log form now, and I can simplify the right-hand side by bringing up both exponents. So I have log base 10 of 6 to the 9th minus log base 10 of 9 to the 6th. Now, subtracting two logs is the same as taking the log of the quotient first divided by the second. That's one of our log properties in our formula sheet. It goes the other way around typically, but we can go backwards with it. And now I'm done. I can compare that z has to be equal to this number right here, 6 to the 9th over 9 to the 6th, which I can just do in my calculator and get a number 18.963 approximately. And the last problem, 18, wants us to expand this to get it to look like this and give what a, b, and c are. So we're going to use our log properties. We have a log property that says that when you're dividing, you can make that division. So I can take the top minus log of the bottom. That's our quotient log property. Then we have a log property right here that says we can take the log of two things being multiplied and change that into the sum of two different logs. Log of the first plus log of the second minus log of z, the sixth still. And then I can bring down the numbers as exponents. So 4 log of x plus 4 log of y minus 6 log of z. And now I'm done. My a is 4, my b is 4, and my c is actually negative 6. If I make this plus or minus, my c is negative 6. All right, I hope this helps.